with linear equation, but we are more now focused on symbols, because that's algebra is about, is to use symbols. And we have rules, right? We have those 10 rules algebra, and we have properties of equation, which kind of like our grammar, which kind of guide us how to play the symbols. Okay. So I'm kind of give you example. Now, so far, when we're doing linear equations, we have a variable, then we have 2 or 3 numbers. And so we're just solving it. Now, if we give another problem, say 5x minus 3 equal to 7, we go through the same process, but each time we have to repeat the same process, and that is not efficient. And so algebra then give us a way to make that as efficient as we can by playing with symbols, because all those problems we can generalize that as ax plus b equal to c, right? So each problem, the number is different, but we can always generate that into this is a number which called coefficient times the variable plus another number which is we call constant and equal to another number which is also a constant. So that can represent all those linear equation problems. And by doing that, then by using the rules algebra, then we can come up with a formula. And with that formula, then we don't have to go through the process again. We just use that formula. Are we good so far?
Yep.
Okay, so how we do that? So we start with this. Ax plus b equal to c. And we know, of course, we're going to have to say what a and b are. And we know that here, a, b, and c, they are all real numbers. Therefore, they follow they have the property of real numbers. And we know a cannot be, is not equal to 0. B and C can be 0, but not A. Because otherwise, if A is 0, then we don't have the unknown term. So that becomes totally different problem. So knowing that, then we say, okay, we know we are get to the point x is equal to something. And so we have to get rid of B and A. And so we only have x, the unknown, on the left-hand side equation, and everything else goes to the right. So how do we do that? And that actually will come from, let me actually put this on the side. So we say A, B, C, all real numbers. And A is not 0. So now we know that we can, in order to get rid of this number from the left-hand side, we just add this opposite. And if we add something on the left, we have add something on the right. So now we're actually using this rule. Let me put on this side. Say if A is equal to B, then A plus C equal to B plus C. So everything we do, we have reason behind it. There's something, the rules are we're using. So now, what do we have? Now we know B plus negative B is 0. So we got AX plus 0. Now on this side, C plus negative B is basically C minus B. And so now we are using the rule B plus A plus negative A equal to 0. That's our inverse rule. And of course, this is AX. This is still C minus B. And that we use this rule, A plus 0 is A. And once we have that, then we know we can multiply 1 over A on both sides of the equation. 1 over A. And that we are using if A is equal to B, then A times C equal B times C. So far, we followed all of the rules. And that's why it's important following the rule, because we are not dealing with any numbers. Everything is a symbols. But then we know on the left-hand side, 1 over A times A, which is reciprocal. A number times the reciprocal is 1. We got 1x. On this side, we can just write as C minus B over A. And so we know A times 1 over A equal to 1. That's our inverse property. So therefore, x is equal to C minus B over A. And we know A times 1 is A. So far we follow all the rules. And we go get this. So from this problem, we get to this solution. And now all we have here are symbols. And that's why we call it formula. So now we can just use symbols now. So in this case, we know A is 3, B is 4, and C is 10. So follow the formula, x is equal to 10 minus 4 over 3. That gives us 6 over 3, that equal to 2. And here A is 5, B is -3, and C is 7. So our x then will be 7 minus -3 over 5, which is 10 over 5 is equal to 2. Good?
Okay.
So that's basically kind of, I'm just showing you how to play the symbols. And that's actually what we do in algebra, is to learn how to play the symbols. Okay, now we have that. So I'll give you a problem, but now you're going to use the formula now. So we say if ax plus b equal to c, then x is b minus c over a. That's what we got. That's formula. So now let's say 3x plus say 5 equal to 9. What is our answer by using the formula? Yeah, you can type on the chat.
I'm kind of stuck here.
Well, think about what is a, so actually it's not b minus c, it should be c minus b. So what is our a, what is our b, and what is c? If you know that, then you can use the formula.
Okay, well, I added 5 to its opposite, so that's 0. That cancels it. And then 9 is 4, because I added that's opposite to it.
Well, now we actually just use this formula because we already did the work. Okay. So in this case, what is our A? What is our B? And this is our C, right?
Okay.
So our A is 3, our B is 5, our C is 9. So therefore, we just use a formula, which already given us. And x equal to c, which is 9, minus b over 3. That's a. So it's 4 over 3. Good?
Oh, that's pretty simple. Okay.
Yep. That's why the formula why we need formulas is because once we have done the work, we don't have to repeat that over and over. Okay, so 4x plus 1 equal to, say, 7, and see what you got. Okay, so we go c minus b. What's c?
Okay, we'll see 7.
Yep, so 7 minus b. B is
That's just 1.
1. And over a is,
Oh. Oh, okay. So I completely messed up there.
that's okay. Yeah, so it will be 6 over 4, right?
Yep.
And here, actually, we can simplify that to 3 over 2. Or we can write that as 1.5 or 1.5. It's a different way of writing the same thing. Good?
Okay.
Okay, let's try 5x plus 3 equal to, let's say, 9. Let's see what you have. Okay, so we got, very good, 9 minus 3 over 5, so 6 over 5. Good?
Mm-hmm.
Okay, let's just try a couple more of that. 3x minus 2 equal to 7.
So with subtraction, do you do anything different, or is it
Well,
about the same?
it's still subtract, but now we're dealing with a negative number because our a is 3, our b is negative 2, our c is 7.
Oh,
So 7 minus negative 2 over 7, 3. So what is 7 minus negative 2?
that's just 5, right?
No,
Or no, no, that's
minus,
negative
minus.
5.
So minus, minus. So that become positive. Or we can think that we can change subtraction to addition. Then we have change number to the opposite. So good.
Oh, okay.
And 7 plus 2 is 9 over 3. And that gives us 3. Good.
Okay.
Okay, let's try that. Very good. So can you simplify that?
This is kind of embarrassing, but I kind of forgot how to simplify fractions.
Okay, well, so now we know 10 is 5 times 2, right?
Mhm.
And 4 is 2 times 2. So we have a common factor of 2, and that means 2 over 2 is 1, so we can cancel. So that gave us 5 over 2.
Okay.
Got it?
Yep.
Okay. Let's just do a couple more. Jade, are you there?
Yep.
Okay, are you good?
Yeah.
Okay, very good. Okay, so we'll try just a couple more on that. 5x minus 4 equal to, let's say, equal to uh, equal to 11.
Not too sure how to simplify this one because
Well, if you got 13 over 5, you cannot simplify it, but it's not 13 over 5 though, because it's 11 minus negative 4. What's 11 minus negative 4?
that's a 7.
So minus minus, that's positive, that's adding 4. Good. Just like we did on here, 7 minus negative 2 is 7 plus 2. Good.
Okay.
Now 11 minus negative 4 is 11 plus 4. Good.
Okay.
Yeah, this actually is from one of the rules we're dealing with subtraction. So when we a plus negative, oh, sorry, a minus b is the same as a number adding its opposite. Good.
Okay.
So if 11 minus negative 4, we can change that to 11 plus, but we're going to change this one to its opposite, which is positive 4. So it becomes 11 plus 4, which is 15 over 5. Good.
Oh, I think I may have added it.
Yep, that's common mistake. So got 3. Okay, so let's just do 2 more, okay? Can just repeat that. Ax plus b is equal to c. Then x is c minus b over a. We're just practicing on that. 5x minus 7 equal to, let's say equal to 6.
So this time it's 13 over 5. Does it feel right?
13 over 5. Very good. X is 13 over 5. Okay, let's do one more. 4x minus 5 equal to, say, equal to 9. Okay, very good. So x is 9 plus 5 over 4. That is 14 over 4. And that's 7 over 2. Very good. Good. All right. So that's what we have for today. Okay.
Okay.
All right. I'll see you next week.
Bye.
Bye.